Section 10.2, Simplifying Radical Expression. We are going to simplify radicals. You can go back and forth with this. If you have two radicals, like square root of AB, that is, you could separate to say the square root of A times the square root of B. Now, there's a couple things about this. It will be simplified if no perfect square factors are inside the radical. A radical cannot contain a fraction, and a radical cannot appear in the denominator. Square root of 4 times 9 is 36, so you can multiply these two together and get square root of 36. Or you could have separated factors, square root of 4 times the square root of 9. You can go back and forth and interchange these concepts. Example 1, square root of 80. We want to break square root of 80 down to two factors where one of the factors is a perfect square root. Square root of 4 is 2, square root of 9 is 3, square root of 16 is 4, square root of 25 is 5, and so on. Now, does 4 go into 80? Yes, 4 goes into 80 20 times. But we can, 20 times. But we can break that down bigger. You can have a larger factor. 9 does not go into 80, but 16 goes into 80. How many times? 5 times. So we're going to break that down to 16 times 5. Now then you can separate to say the square root of 16 times the square root of 5. The square root of 16 is 4. Cannot take the square root of 5, so it stays inside. You can also skip the step and go directly to that step. Example B, square root of 54. We want to try to find the largest two factors where one of the factors is the largest perfect square root. Does 4 go into 54 evenly? No. Does 9 go into 54 evenly? Yes. How many times? 6 times. So I'm going to break that down to 9 times 6. Now, how do you know you're done and you can't go any further? Because 6, the two factors of 6 are 2 and 3. And 2 is prime and 3 is prime. So you know you can't break it down any further. Square root of 9 is 3, so it comes out of the radical. We cannot take the square root of 6, so it stays inside the radical. Square root of 180. Well, again, I want to go through my perfect square roots. Does 4 go into 180 evenly? It goes into it 45 times. If 4 goes, you should always try 16. So, 180 divided by 16 is 11.25. So 16 does not go. Does 9 go into 180? Yes, 20 times. So if 4 goes and 9 goes, then you know that 36 goes. And 180 divided by 36 is 5. So I'm going to break this down to 36 times 5. Square root of 36 is 6. Square root of 5 stays inside the radical. Square root of 72. Well, the most common two factors of 72 is 9 times 8. Square root of 9 is 3. Square root of 8. But we're not done because the 8 can be broken down to 4 times 2. And square root of 4 is 2, and when we take it out of the radical, we then multiply it times 3 and get 6 square root of 2. Now you could have done this another way. Remember what I said? You want to try to find the largest perfect square root that goes into this number. 9 is not the largest perfect square root. 36 is. 36 times 2. And the square root of 36 is 6. Now notice you get the same answer, but what a lot of people do, they stop right here, 3 square root of 8. And that would be wrong because 8 can be broken down. So that's why I stress to you that you want to try to find the largest perfect square that goes into those numbers. Example 2, square root of 2 times the square root of 14. I am going to multiply those two together and get square root of 28. Now, square root of 28, I'm going to break that down to square root of 4 times 7. Square root of 4 is 2. Cannot take the square root of 7. Square root of 7. Example B, I'm going to multiply these two together, get square root of 50. Now, I am going to try to find what is the largest perfect square that goes into 50? 25. 25 times 2. Notice I always put the perfect square first. Square root of 25 is 5, so it comes out of the radical, and square root of 2 cannot take it, it stays inside the radical. Example 2c, I am going to multiply square root of 6 times the square root of 8, it's the square root of 48. Now, I'm going to be going through my perfect squares. Square root of 4 is 2. 4 goes into 48. The next perfect square is 9. And the next is 16. Now remember what I said. If 4 goes, you should always try 16. And 16 goes into 48 3 times. Square root of 16 is 4. It comes outside the radical. Get 4 square root of 3. Now, in example D, the 3 is outside the radical. So that would be considered the coefficient. So I'm going to multiply my coefficients together. This square root of 24 is understood to be a 1. So multiply 3 times 1 is 3. And then 2 times 24 is 48. I'm going to break 48 down to 16 times 3. Square root of 16 is 4. It comes out, and I am going to multiply it times the 3. 4 times 3 is 12. Square root of 3. Okay, example 3. Now we have variables. I'm going to back up for just a minute. I'm going to use this panel to talk about the square root of variables. If you had the square root of x to the 4th, you would divide the root, which is understood to be a 2. If there's no number, it's understood to be a 2 right here. And 4 divided by 2 is 2. So the square root of x squared is x. The square root of x to the 6, again, I'm going to divide 6 divided by 2 and get 3, so it's x to the 3rd. The square root of x to the 8th is x to the 4th. The square root of x to the 10th is x to the 5th. The square root of x to the 14th, again, I'm dividing 2 into the exponent, get x to the 7th. So, as you notice, 2 goes into every single even number. So if they're even, they're good. But if you had, for example, x to the 3rd, you would have to break that down to the closest number to 3 without going over, so you'd have to go below. The closest number to 3 that 2 goes into, x squared. And then you would have to add an x to the 1 power. Now the square root of x squared is x. Cannot take the square root of this x, so it stays inside the radical. So another example would be x to the 7th. We have to break that down to x to the 6 times x to the 1 power. The square root of x to the 6 is x to the 3rd. Cannot take the square root of x, so it stays inside the radical. Example 3. This 2 is the coefficient outside the radical. We just keep bringing it down. Now 90, we have to break that down to 9 times 10. X to the third, that's an odd number, so I need to break it down to the closest even number, which is x squared times x. If you wrote x to the 1 power, that's fine, but you don't have to. Y to the fourth, I can break that. I don't need to break that down because I can take the square root of y to the fourth, so I'm just going to carry it down. And then z to the fifth, that is z to the fourth times z to the 1 power. Now, I have to take each one of these separately. If I can take the square root of it, it comes out of the radical. If I cannot, it stays in. So I'm going to go ahead and write my radical. Square root of 9 is 3, so it comes outside, and I multiply it times that 2 to give me 6. Square root of 10, cannot take the square root of 10, so it stays inside. Square root of x squared is x, so it comes outside. Square root of this x, I cannot take the square root of x, so it stays in. Square root of y to the fourth is y to the second, and it comes outside. Square root of z to the fourth is z to the second, and it comes outside. Cannot take the square root of z to the 1 power, so it stays inside the radical. Example 3b, I need to break square root of 32 down. Now, I'm not going to use 4 times 8, because if you use 4 times 8, you can take the square root of 2, and then 8 can be broken down to 4 times 2. So, you don't want to use 4 times 2, you want to use the largest perfect square, which is 16 times 2. R to the second is an even number, I'm good, I'm going to leave it. K to the fourth is even. So it's k to the fourth. V to the fifth is, I'm going to break that down to the v to the fourth times v. Square root of 16 is 4. It comes out of the radical. Square root of 2 stays in. Square root of r squared is r because I'm